of carboxylic acid. In the last class, what we have discussed, okay, we this cross aldol Canizaro we have completed. We have also completed how to detect the aldehydes and ketones. Aldehyde and ketones can react with Tollens reagent, ammonical silver nitrate, and they're going to give the silver mirror, okay, deposit of silver. And because this happens because the aldehyde and ketones have this reducing hydrogen. Got it? Aldehydes have this. Ketones do not have any reducing hydrogen, so they do not respond to this test. Then you have Felling's test. Okay. What care need to be taken for the Felling's test? Could you just quickly tell me who will not give Felling's test? Marwa, can you hear my voice? Am I audible?
Yes.
So who will not give? Exception to Felling's. Means they are aldehyde, but in spite of being aldehyde, they will not give the test. What type of aldehyde will not respond to Felling's test? Just try to recall. Jaslyn, Marwa, you can, Aisha, you can help Marwa to get the answer. What type of aldehyde, in spite of being aldehyde, they do not give the test?
Aromatic aldehydes.
Exactly, aromatic aldehyde. Yeah. Be careful about it because in the school Viva also they ask, right? So this we have seen. This everybody should remember it. Okay, that's what we have discussed. If you can do this, okay, very important. This is the summary of whole laboratory test identification method to detect aldehydes, ketones. Okay, there are various methods. Okay, got it. And now we need to move on to carboxylic acid. Okay, and we have structure of carboxylic acids, right? Nomenclature that carboxylic acid is the principal functional group that we know. Clear? And oic acid is the suffix. If the carboxylic acid is directly connected to the cyclic ring, then the suffix is carboxylic acid. Got it? There are some carboxylic acid which are very common, and for them the common name is more common than the IUPAC. You are expected to know their common name also. Got it? Benzoic acid, which is benzene carboxylic acid. Okay, phthalic acid, benzene 1,2-dicarboxylic acid. Okay. Some common carboxylic acids which are very acetic acid, you know, acetic acid that is also very much common. Formic acid, methanoic acid, formic acid is methanoic acid that you must have been studying from your class 10th, right? So that we are not discussed because I know you know that oxalic acid. This is oxalic acid. This you must remember. We have seen oxalic acid in coordination compound also. This is the common name. And IUPAC name is ethane 1,2-dicarboxylic acid. Is it clear? Am I audible to all of you?
Yes, sir.
Okay, good. Let's discuss some more names. Okay. Now, what is the name of these three carboxylic acids? IUPAC name. Yeah. What is the IUPAC name? What is the IUPAC name of this compound? Yeah, Marwa, tell me quickly. This is the parent chain. Got it? What is the IUPAC name of this first compound? Yeah, Aisha, Jaslin, tell me quickly. Very easy. A numbering already I have done. So now you can easily do it. What is the IUPAC name of the first compound? Jaslin, what is the answer? Just help me out to solve this problem. First one, this is spent 5 carbon atom. Got it? And 2 in oic acid or 1 oic acid. Got it? And at the fourth carbon you have OH, but that is the junior functional group. It is called hydroxy. Got it?
Yes, sir.
Hydroxy and 2 enoic acid. Right? Hydroxy, it is alcohol if it is the principal functional group, but there is some more other functional group which is having higher priority than the alcohol. Then that functional group is treated as the parent functional group, and OH is treated as a junior functional group. Got it? What about this one? This is the parent chain. Got it? And while doing the numbering, while counting the numbering, don't count some of the carbon of the ring and some of the carbon of the open chain. Not like that. This is the parent chain. Why this is the parent chain?
The longest chain.
Yeah, longest chain, and it is connected to the principal function group. That makes it the parent chain because COH is directly linked to it. Got it? Clear or not?
Yes, sir.
So cyclopent. And from where should I start the numbering? From the principal functional
Carboxylate.
group, it's carboxylic acid, right? But don't count that COH. Don't do this. Okay, don't take that one. Okay, numbering should be done either on the cyclic ring or outside the linear chain. Okay, any one you can adopt, right? So this is cyclohexene, and I'm not going to use oic acid. That is if it is a linear chain. And if it is COH is connected to carboxylic outside the cyclic ring, you should sorry, cyclopent 1 in either so what I was telling that COH is directly connected to the cyclic ring. Count the number of the cyclic ring. Okay, 5 carbon atom pent, and don't use oic acid here. That's what I was telling. Use the suffix carboxylic acid for cyclic. And whatever the side chain are there, junior functional groups are there, they are going to come in the prefixes before the name of the word root. Okay. And this is 3-methyl. Got it? So this I hope clear to everyone. Next question. So what is the name of the parent chain? Yeah, pardon?
There's a 2,4,6 nitrobenzoic acid.
Exactly, 2,4,6 trinitrobenzoic acid. Because I will start the counting from here, right? Got it? Now, we will move on to the preparation of carboxylic acid, how to prepare them. Okay. Preparation of carboxylic acid by oxidation of alkenes. But alkenes can get oxidized with acidified potassium permanganate and heating. But whether they are going to get carboxylic acid or not, that depends on their structure. Okay, so CH3, CH, CH, CH. So this is the carboxylic, this is the alkene. Okay, keep in mind the alkene should not have two carbon atoms. It should not be disubstituted on one carbon. Got it? So it should not be disubstituted. Is it clear? So you should have one H on the carbon, and if you oxidize it with KMnO4H plus acidified potassium permanganate, the alkene will break and you will end up with COOH. Got it?
Yes.
But suppose if any end of the double bond has two carbon atoms, like this one, and if you oxidize it, the double bond will break, but the upper end will change to ketone because ketones do not get oxidized further easily. Okay, we will oxidize them in special conditions, but you cut this, this is H, so this is going to become COOH. Got it? Is it clear or not? In this case, both became carboxylic acid. Got it? Clear?
Yes.
Yes, sir.
Okay. So now suppose this is oxidation of alkenes. Similarly, alcohols is the most common method. Oxidation of alcohol is the most common method for the preparation of carboxylic acids. But which type of alcohol can give carboxylic acid upon oxidation? Which type of alcohol? There were three types of alcohol, like primary alcohol. Primary alcohol, the characteristic is CH2OH. Secondary alcohol, the characteristic is CHOH. And tertiary alcohol, this is the characteristic. So first of all, we need to check that which kind of alcohol can get oxidized, whether the alcohol can get oxidized or not. Okay. And if they get oxidized, whether they are going to get the carboxylic acid or not. Got it? So primary alcohol, we have seen they get oxidized by in two stages. Okay. Marva, first you remove the H and H. So when you remove the H and H, you get C double bond O H. Got it? Is it clear? And with a strong oxidizing agent, this aldehyde we have seen already that aldehydes are easy to oxidize because of this reducing hydrogen. Got it? Is it clear or not? So aldehyde will not stop if you have taken strong oxidizing agents. It will get oxidized completely up to carboxylic acid. Got it? 2-degree alcohols can get oxidized only in one stage, right? Whether irrespective of you are taken the strong oxidizing agent or weak, they will get oxidized only at one level and they will end up with the ketone. So keep the carbon atom same, put the oxygen where it was connected earlier on the middle carbon. Oxidation doesn't change the position. Oxidation doesn't change the position of oxygen. You need to keep the oxygen wherever it was initially present on the alcohol. But this is a ketone. Okay. And ketone actually, ketones are very difficult to oxidize. So the reaction will stop at this stage. And for tertiary alcohol, we know there is no oxidation. Strong oxidizing agents can can be used to convert the primary alcohol to carboxylic acid. Can anyone give me the name of strong oxidizing agents? What come under strong oxidizing agent?
Sodium hydroxide.
Sodium hydroxide is used for the hydrolysis. Some strong oxidizing agent, they have lot of oxygen in their formula. That's why they are oxidizing agent. Got it? Is it clear or not? So can you give me some oxidizing agent which have a lot of oxygen in them? What are those oxidizing agent?
Hydrogen peroxide.
Hydrogen peroxide is also an oxidizing agent. Very good. Yeah, that is there. But oxidation for alcohols, that is not wrong, but it is commonly carried out by more strong oxidizing agent. That is K2CR2O7. potassium dichromate, acidified. Got it? Is it clear or not?
Yeah.
Or KMnO4, potassium permanganate. And in your school practicals also, you might have used them, you might have seen them. They in redox also, they are the most common oxidizing agent, strong oxidizing agent, which can convert the alcohol to carboxylic acid. Got it? Is it clear or not? Any doubts in this? What about the next one? Next one, okay, and the K2Cr27 is also the other form of CrO3, and this is chromium trioxide in acidic medium. Got it? This is known as Jones reagent. This is also for the alcohol, it is an oxidizing, strong oxidizing agent. Got it? Is it clear? Though H2O2 is there, but that H2O2 has a disadvantage that it can decompose in sunlight. Got it? So we don't prefer H2O2. We prefer the more common oxidizing agent like potassium permanganate, acidified potassium permanganate. Is it clear or not? And which is the other reagent? Marwa, can you speak it out loud for me?
Yes, sir.
Yeah. What are the oxidizing agent which can convert the alcohol to primary alcohol to carboxylic acid? What are the oxidizing agents which can convert the primary alcohol to carboxylic acid directly? Strong oxidizing agent. What are those two strong oxidizing agent? The name. What is the name?
Potassium permanganate. Potassium dichromate.
That acidified potassium permanganate. Yes, the lower one is acidified potassium permanganate. Yes, absolutely correct. What about this one? Acidified potassium dichromate. Got it? And this CrO3 acidic medium, Jaslene, it is chromium trioxide in aqueous acetone. This is also known by the name of Jones reagent. Got it?
Yes, sir.
Yes. So primary alcohol only can give us carboxylic acid directly. Secondary alcohol will not give us directly carboxylic acids. And tertiary alcohols have very different kind of problem. They don't get oxidized. Okay. So this I hope is clear. Oxidation preparation by oxidizing alcohols. So let's do one conversion. Can you convert ethane to ethanoic acid? How will you convert? Or I can give you a hint. If you have alkane, alkane can be easily converted to alkyl chloride. Got it?
Yes, sir.
So how we will convert it to ethyl chloride or bromide? By doing Jaslin, Aisha, Marwa, tell me. This is very, very important. So whenever you have alkane, use photochlorination method. Got it? Take chlorine in the presence of sunlight or UV light, right? And that will convert the ethane to chloroethane. Now you want carboxylic acid which has oxygen in it. So at least get the compound with one oxygen. What is that compound which is of one oxygen? Alcohol. Okay. Use KOH aqueous. Jaslene, are you getting my point? If you want carboxylic acid, at least, so carboxylic acid has many oxygen, so at least get one OH. Got it? Make it an alcohol, but to get an alcohol, you need first chlorine, which can be substituted aqueous KOH substitution. Is this clear or not? Now, once you have the alcohol, primary alcohol, you can oxidize it. Take acidified potassium permanganate. Take acidified potassium dichromate. Is this clear? Clear or not?
Yeah.
Got it? So next question. From the chapter of alcohols and from the chapter of carboxylic acid combined. Okay, I have given you propane. Clear? And can you convert it to propanoic acid? Very, very important. And this is the right time to do such questions because they will revise your alcohol chapter and carboxylic acids. Both the chapters will be revised. Got it?
Yes.
So first get the OH, then do this, then get COH. Okay, that's what you need to remember. So how to get the OH and where? Should I get OH on this outer carbon or should I get OH on the inner carbon?
Inner
Getting a
carbon.
point. Should I get the OH on the outer carbon or the inner carbon? This should OH be connected like this or like this? On the outer carbon or on the inner carbon? So that You can make out very easily if you try to look at the product. In the product, where is the COH? COH is on the outer carbon. Got it? If COH is on the outer carbon, okay, carboxylic acid, you must get your OH at that carbon. Got it? Is it clear or not? So you need to get OH here. Very important question from both the chapter. Just a quick recap. For the preparation of alcohols also, it is a quick recap and also a quick way to revise the preparation of carboxylic acid also. So by using which reagent we can add water in this way? What is the method? Is it Markovnikov addition or anti-Markovnikov addition? Markovnikov is rich becoming more rich. Rich means the carbon atom carrying hydrogen. So are the hydrogen getting added to the carbon atom where you have more hydrogen, or the hydrogen is getting added to the carbon atom having less hydrogens? You should look at these two carbon atoms which are connected by double bond. Yeah, Aisha, is it Markovnikov or anti-Markovnikov addition? Jesslyn, Marwa, tell me. This is Markovnikov or anti-Markovnikov addition?
Anti-Markovnikov?
Yeah, anti-Markovnikov, because the H is not going to the carbon which is carrying more hydrogens. Not like that. In fact, it is the reverse which is happening. H is going to the carbon atom which is having less hydrogens. Okay. Anti-Markovnikov addition of water. Is it clear? But how we add water in anti-Markovnikov way? What was the method which we discussed for alkenes? We discussed it in the preparation of carboxylic acids. Sorry, alcohols. Tell me quickly. Anti-Markovnikov addition. Aisha, Marwa, how you can do? What was the reagent? We use hydroboration oxidation. Got it? And the reagent was BH3, THF. NaOH and H2O. Okay. This was the reagent which can be used to do the anti-Markovnikov addition of water, and that whole process we have discussed in the alcohol chapter is known as hydroboration and oxidation. I asked you to remember the name of the movie channel, HBO. Okay, got it? So what we are going to get? We are going to get this alcohol, CH3, CH2, CH2OH. Now we have to oxidize it. Okay. How we are going to oxidize it? You can take K2Cr2 Got it? Clear
Yes,
or
sir.
not? Okay, so do remember, so how can we prepare carboxylic acid? Okay, clear? By oxidation of alkenes. Alkenes, when get oxidized, their double bond breaks and they are splitted into two fragments with carboxylic acid. Okay, clear? Alcohols, primary alcohol can give you carboxylic acid. Secondary alcohol will not give you carboxylic acid, they will give you ketones. Primary alcohol will give you carboxylic acid, and that is only under certain circumstances when you actually uh, take strong oxidizing agent. Don't take mild, don't take PCC. Got it? Because if you are taking PCC, that will oxidize the primary alcohol to partially, not completely, to an LDN. Getting my point? So let's do some more questions and more methods. By doing these questions, we are revising both alcohol chapter and aldehyde ketones chapter and carboxylic acid. They are all connected, right? Concentrated H2SO4 heat, you got X. X is treated with hot acidified potassium permanganate solution. You got Y. What are X and Y? What is X? All of you know it. What happens to alcohols when they are heated with concentrated H2SO? Concentrated H2SO4 doesn't have water in it, much water in it, so it has a tendency to absorb more water. Got it? Is that clear? So what is X? What is the IUPAC name of X?
Para-hydroxy.
Cyclohexane. Yes.
Yes. Also, sorry, cycling.
Yeah, cyclohexene because, right? Right, Aisha?
Yes.
Because water is getting removed, H and OH by heating with concentrated H2SO, and you're going to form a double. Now, what will happen with acidified potassium permanganate? What happened to alkene? When you treat them with acidified potassium permanganate, the double bond is cleaved. Got it? It is oxidized, it is cleaved. Got it? And both the carbon atom, you can think of it in this way. First the double bond breaks and you get double bond O, double bond O, just like the ozonolysis. Okay, but you have aldehydes. Okay, and because you have aldehydes, you are going to oxidize them to carboxylic acid. Got it? Is it clear or not?
Yes, sir.
So this is hexane 1,6-dioic acid. Common name is adipic acid. It is an ingredient of nylon 6,6. Okay, it is used for making nylon. X is clear. Y is clear. Any doubts in this? Okay, let's move on to the next method. Preparation of carboxylic acid from alkyl halides. So alkyl halide, how you can convert them to carboxylic acid? What are the ways? Yeah, Jaslyn, Aisha, Marwa, tell me. What are the methods? Any idea? Suppose if I ask you, this is the alkyl halide. How will you do that? And keep a track on number of carbon atom. Are they same or they have increased? Got it? Keep a track on them. So how will you convert? Aisha, can you tell me the sequence of reagents which are needed to convert ethyl bromide to ethanoic acid?
We use a cyanide KCN.
Yeah, but cyanide will add. That is also a method. But cyanide will add one extra carbon atom. Got it? That is a method, very important method. But keep a track on number of carbon atom. Are we having the same number of carbon atom?
No.
Just check in the reactant and the product. Or the carbon atoms are increased. How many carbon atoms are there? 2. And here also we have 2. Getting my point? So should we add casein? That is also a method. Okay, I'm not denying that. But that method will add extra carbon. So do we need to put extra carbon, or just we need to continue with the same number of carbon atom? First you should keep in mind this. So we need to continue with the same number of carbon atom, because two carbons are there on the ethyl bromoethane and two carbons are there in the acetic acid. Got it? Is it
Yes,
clear or
sir.
not? Okay. Next is, so what we should do?
Alcohol.
Yeah, first get one OH at least. OH check first. Right? And then oxidize it. Then you can oxidize. It is a primary alcohol. Okay, so first get at least one OH, make it an alcohol, then oxidize it. Using KMnO4H plus 8. Got it? Clear or not? But the next method is, suppose if I ask you to convert ethyl bromide or bromoethane to propanoic acid, does it have same number of carbon atom or they have increased? Ethyl bromide and propanoic acid.
Yes, same.
Ethyl bromide and propanoic acid. Prop is 3 carbon atom, right? COOH. This is propanoic acid. Clear?
Yeah, thank you.
Bromoethane and propanoic acid. Okay. While counting the carbon atom, you should count the carbon atom of the carboxylic acid also. Okay. And by taking into account the carboxylic acid, we can make out that the carbon atoms have increased. They have changed from 2 to 3. Got it? Clear?
Yes, sir.
Now what we need to do? You need to increase the number of carbon atoms. So you were telling me one method, Aisha. What was that method? In the previous question was telling me, but I asked you to use it some other elsewhere, and this is the place where you can use it, because that method was increasing the number of carbon atoms. Got it?
Yes, sir.
So how can we increase the number of carbon atoms? You can use
KCN.
KCN. Yes, exactly. So KCN will cause nucleophilic substitution reaction. CH3, CH2, Cl. Got it?
AF.
And now you can hydrolyze it. Excess of water will break the C multiple bond, triple bond N to carboxylic acid. Is it clear or not?
Yes, sir.
Got it? Okay. So this is very, very important basic thing. But there is one more method which you can use. Marwa, can you help me out? Is there any other method by which you can increase the number of carbon atoms? That is through Grignard. Okay. First react with magnesium. Okay. Heat it with magnesium and in the presence of ether. Ether is used for the dissolution. Okay, because magnesium is solid. Heat it in the presence of ether. What will happen? It will change to CH3 CH2 MgBr. Got it? And you know Mg is plus 2 minus minus. Okay. So the carbon is minus. Got it? Is it clear? Now think that you need to what extra you need to put COH. Okay. So that COH can be put by reacting with CO2. This carbon minus is going to combine with the CO2 molecule. And the CO2 molecule, when the carbon of the Grignard is getting attached to it, CO2 molecule is already made 4 bonds. So if the Grignard is getting attached to it, you need to make one of the CO bond as C single bond O minus. Getting my point? In MgBr you can put it here. Got it? Is it clear or not?
Yes.
Now you can put water. Water will make the CO minus as COOH. So this is a very, very important reaction. Is it clear? The mechanism is nucleophilic addition reaction. You can use any one of them. Either go through KCN or use Grignard. Getting my point or not? Okay, let me give you some questions. I want you to convert benzene to bromobenzene. Got it? And bromobenzene, I want you to convert it ultimately up to carboxylic acid, benzoic acid. How you are going to get bromobenzene first? This is the first hurdle. Okay. And the second one is to convert it to carboxylic acid. And we can clearly make out that there's some extra carboxylic acid COH is being added. Got it? Is it clear?
Yes, sir.
So first of all, tell me, this is from the haloalkane chapter. Okay. So how are we going to add bromo, make it bromobenzene? Benzene to bromobenzene. How we are going to do that? Yeah, Aisha, how to get bromobenzene? Jasleen, how to get bromobenzene? Tell me quickly. Marwa,
By using Lewis acid.
by using,
Lewis acid.
yes, Lewis acid, but you need to pick the reagent also. Got it? Lewis acid is correct, but the reagent also. Okay, reagent also. Got it? Is this clear or not? So Lewis acid along with Jasleen, what you need to take? That's absolutely correct. What we need to take? Tell me. Hmm. FeBr3 and bromine, yes, absolutely correct. Br2 and Fe also will work, or Marwa, is it clear or not? FeBr3. Yes.
Yes.
Okay, once you have the Br, how you will get COOH? One thing is sure that we need to have some extra carbon. Somehow you should put reagent which should contain extra carbon. Got it? So extra carbon you need to take care of. Whether you need to put some carbon containing reagent or not, that you can very easily figure out by looking at the reactant and product and the carbon contained in them. So you can use the more general method, which is the lower one. You can see the above conversion. I hope all of you can see that. And by using above conversion, the lower method, you can easily achieve the conversion of bromobenzene to benzoic acid. Clear? So how we are going to convert the bromobenzene to benzoic acid? Tell me quickly, what should I use? Yeah, Isha. Bromobenzene we have already attained. How to convert it to benzoic acid? First, make it breakdown by heating with magnesium and ether. Okay, then you need this COH. So think of CO2. Got it? Use CO2 and CH plus. Last step is H plus to make it COOH. Jaslene, is it clear? Marwa, clear?
Yes, sir.
Yes, sir.
Yes, sir.
This is the way to convert. Step up of carboxylic. Step up means you are increasing the number of carbon. Okay. Let's learn next method with directly with the help of example only. First, I want you to convert the benzene to toluene. Okay. Now I want you to convert the toluene with chlorine, excess of chlorine. Got it? In the presence of sunlight. That is photochlorination. Okay. You will get X or you will get Y. Now I want you to do the hydrolysis of Y with aqueous KOH. You will get Z. This is the new method, but instead of giving it any name, I started it with directly giving you in the form of a question. By learning the question, because it's not entirely new, it's almost being done in previous chapters, so that's why I'm giving it to you in the form of question. So tell me quickly, what is X? That is from class 11 and mostly from class 11, aromatic hydrocarbon. But 11th and 12th both are, as far as organic is concerned, they are very much interrelated. Got it? So what is X?
Ether.
That has oxygen. I need to bring CH3 to the, I need to put CH3 on the benzene.
NaOH.
NaOH will bring OH. Any other reagent?
Don't we have to convert it into phenol first?
No need to convert it to phenol, just take similar to that.
Oh, okay.
Yeah, what we need to take. CH3Cl, AlCl3. Got it?
Yes, sir.
AlCl3 will remove the Cl minus, make it CH3 plus, and that CH3 plus will get attached to the benzene. Got it?
Yes.
This is Friedel-Crafts alkylation. Okay, and we have acylation. Acylation is going to give us aromatic ketones and aldehydes. What about this one, Cl2H-neo?
CH2Cl with the benzene.
CH2Cl. Okay, yeah, with one chlorine it will happen one time. But with two chlorine it may happen two times. Okay, but you have taken excess amount of chlorine. So all the hydrogen of this alkyl group are going to be substituted with Cl. Got it? Trichloro it is going to be like this: benzene ring with Cl, Cl and Cl. You will have OH, OH and OH. Got it? Once you hydrolyze it, you will have 3 OH. Is it clear or not? All the 3 will be replaced. But you know, multiple OH on one carbon are unstable, water is removed. Out of the 3 OH, water is removed from 2, and you are going to get it as benzoic acid. Is it clear? Got it? So
Yes.
trichloro derivatives are going to undergo hydrolysis. They are going to give us benzoic acid. Okay. There is also one direct method of preparation of aromatic carboxylic acids. Aromatic carboxylic acid can be prepared by vigorous oxidation of the alkyl side chain. Alkyl side chain means what? The alkyl group which we are having connected to the benzene ring. Aromatic carboxylic acids can be prepared by vigorous oxidation of the alkyl side chain. So in that oxidation, what happens is the whole side chain, carbon side chain, alkyl side chain, which is lying outside the benzene ring, get oxidized completely. Okay. And that happens with KMnO4 in basic medium. Okay. Alkaline potassium permanganate or K2Cr2O7. Any one of the oxidizing agent you can take. This is the alkyl side chain. It get completely oxidized to benzoic acid. If you have basic medium use, you will have initially CO minus. So if basic medium is there, to get the carboxylic acid, you need to put H plus. Got it? Is it clear or not? Getting my point or
Yes.
not? So, and the whole side chain will get oxidized. Suppose if I take, and irrespective of the number of carbon atom, okay, the primary, secondary side chain get oxidized, the tertiary side chain doesn't get oxidized, right? It remains as it is. Suppose you have CH3, CH2, CH3. And propyl group. It should not be a tertiary group. Got it? So what is the IUPAC name of the product? What I told you, irrespective of the number of carbon atom, the side chain connected to the alkyl side chain connected to the benzene ring will get oxidized completely to carboxylic acid. So whatever the number of carbon atom you have, the side chain will get completely broken down to what? It will get broken down to carboxylic acid, right? So what is the IUPAC name of the product, Aisha? You have CH3 that will completely oxidize to. What should I write here? Jasleen, Aisha, Marwa, tell me. At the top position. Got entire side chain will go away. What should I write here? In place of ethyl, carboxylic acid. Okay. All the rest of the carbon will come out. And here you had propyl, Marwa. What should I write? COOH. Is it clear or not?
Yes, sir.
So you have carboxylic acid, but it should not be tertiary. That thing you should keep in mind. So the whole alkyl side chain will go away and just you will be left with one COOH group. Is it clear? So this methyl benzene can be converted to benzoic acid directly also by doing the oxidation of side chain. Getting my point or not?
Yes, sir.
Or you can put Cl, but how many Cl you need to put to get carboxylic acid? You need to put 3 Cl. Got it? If you put 3 Cl, those 3 Cl will be replaced by 3 OH groups. And 3 OH group water will come out and you will have C double bond O and OH. Directly, if it is outside benzene, it can be oxidized. Very, very important method. So how will you convert ethyl benzene to benzoic acid?
KMNO4.
Yeah, if KMNO4 and
Heat.
yeah, KMNO4 OH minus heat. And because it is OH minus, you need to put H plus also in the last step so that you can get COOH. Got it? Clear?
So we will get some product before this, right?
Hmm?
We'll get potassium benzoate before this.
Yeah, if you
Should we
don't
mention that?
put H plus or water, it will stop at because you are taking basic medium. It is going to be with potassium benzoate. So last step we sometimes you don't write it also. Okay, but it is better to write. And if you take acidified potassium dichromate, then you don't have to put mention H plus because there the conditions are already acidic conditions already. The oxidation after oxidation, you will be end up with carboxylic acid. Getting my point or not?
Yes.
Okay. So this is a very, very important method. But if you have a methyl group and tertiary butyl group, methyl, ethyl, or any group, okay, any group on this, and if I oxidize it, what will happen?
Carboxylic acid.
How many carboxylic acid?
2.
2 carboxylic acid or just one carboxylic acid. So the alkyl side chain get oxidized to carboxylic acid, alkyl side chain of the benzene ring. But what I told that it should not be tertiary. This is tertiary carbon now.
Yeah.
Tertiary butyl, that will not get oxidized. Is it clear or not? Tertiary carbon will not get oxidized. Other than tertiary, if you take butyl, propyl, isopropyl, pentyl, all of them will get oxidized to COOH. So we have seen today primary alcohol, how to get carboxylic acids. One is through oxidation of alkenes, but that will break the double bond with acidified potassium permanganate, and that alkene will be cut into two carboxylic acids. By oxidation of primary alcohols, because secondary alcohols will give us ketone and tertiary alcohol do not get oxidized. Take strong oxidizing agent only. Otherwise, if you take PCC, you will get aldehyde. Got it? Next is, these are some methods which were connected to both alcohols and carboxylic acid chapter. So, okay, next is, if you want to increase carbon atom, take halogen, KCN, and hydrolysis, or this is the most common method, make it Grignard and use CO2. By oxidation of alkyl side chain or by hydrolysis of trichlorides will give you carboxylic acids. That's what we discussed today. So I hope this is clear. Okay, and just we will be taking some more questions which involve all the chapters. Okay, so that we can recover and revise all the concepts. Okay, in carboxylic acids.